Assalamualaikum. My name is Muhammad Izzuddin bin Shabrin. My kit number A21EC0083. And today I will be explaining my part, the data mining task classification. So the data I use is the bank.csv. So first I will uh, upload the data. And by the way, I'm using Alteryx designer. It is also a data mining tools that we can use. So first we drag here the input data tools, and then set up connection, files, and then select file. And then here is the file that I use. Okay, and then open. And then right. And then so after that we I proceed with data pre-processing. So first we go to the preparation tab here, and then we go to what is this? This uh, we go to select. Yes. So here we select what select this does is it will uh so when we upload this file bank.csv, all the type is default to v underscore string. So however, some of the variable here not necessarily is type v string. So here we can change it by using this select tool. So here, okay, so I will just go to here and then something see balance. Okay, so maybe I use integer string d integer here, then with duration also is integer, then a campaign and campaign and pdx. Okay, so that's it, and then we run it. So so we have this here, so we just change it, then we run. Okay, so there's no problem here. So then we proceed. So here the data, then we proceed to data thing. So what here is do here it will if there are trailing hidden and trailing white space, it will remove it and will replace null with blanks or zero for numeric field. Then we run it. Okay, then it's done. So after that, because the sample is very big, so uh, I will reduce the size sample. Although I said reduce, it still have the same volume of data that we can analyze, although the data is reduced. So don't worry. So here, uh, so I think just here, one of every n rows. So here we will choose about maybe 10, every 10 rows. Then we write, sorry, I forgot. And then we go here, select all, and then run. Then so after that, the process for data pre-processing is already done. And then we're moving on to the classification. So here we go to the machine learning tab here, and then, oh no, before that, we go to the preparations here, and then we must first create two sample, the estimate sample and the validation sample. So here we put the estimation sample percent and validation sample percent. So I will just leave it like this. Okay, and then run. Okay, then with that, and then I will proceed to the classification. So here we have this SSM modeling. So this is a tool that make it most easier to do the classification analysis. So and then we drag here, and then we connect it with the E here, the estimation value sample, and then okay, first we run it. Okay, okay. After already run, and then we can start the assisted modeling. So we press here, wait for a bit, okay, and then we go start building. So here is all the variable that the data set has, such as age, job, measure, education, default, balance, housing, loan, contact, day, month, duration, campaign, key days, previous quick account deposit. So here, this is the that target that we want to use, or we want to predict using this classification. So here I want to predict deposit, or which is a variable that uh, whether the customer is subscribed to the term deposit or not. So we will use this classification analysis to predict and compare it with the original value. Okay. Then here we have two, classification and integration. However, we want to do classification, so we choose this. And then proceed to next. So continue. And then here step by step. Uh, okay, so here we must change the data type here. However, because this is assisted modeling, it's already changed it to the recommended data type. So here we can also change it to categorical or ID. However, it is recommended for numeric data type. So we just leave it like that. And then moving on to next step. So the next step is actually apa data cleaning. So we already did the data cleaning just earlier during the data pre-processing process. So there's no need to do this again. So we just proceed next. So here, so okay. So this is where we choose the feature that we want to use. So what is this? What will we use this feature? So we will use this feature to predict the value or the outcome of the deposit that we chose earlier. So the existing modeling also already help us. They already give the information about each feature. So like for example, this feature default here is actually a very weakly associated with target, which means that it is not really suitable to help to predict the value of our outcome, the deposit that we choose earlier. So we just ignore it, we just untick this, and also learn also weak here, so I just untick, and then okay, this is all very good predictor, so we just choose this. Okay, then next. So here there are four uh, algorithm, decision tree, logistic regression, enterprise, and XGBoost. So you can choose either one or all these algorithm. So in my case, I will choose all the algorithm because I want to compare the accuracy, and then I will choose with the higher the algorithm with the higher accuracy. So then I will proceed with that. Okay, current selected algorithm. Okay, then done. So here, this is the leaderboard. So we can see here, this is the leaderboard to show the accuracy of this algorithm compared to others. So XGBoost is the highest algorithm with the highest the first algorithm with the highest accuracy with 84.1%, and then followed by logistic regression with 81.7%, and then forest with 79.7%, and then decision tree with 76%. So here we also have the model overview there, the AUC. So the AUC value is the more near to 1.0, the more accurate it is. So it's just like percentage. This is like 91% true to the accurate value. And then we also have the ROC chart. Here it will compare the four algorithm here. And then we could go to the interpretation, and then we can see here this bar graph here, which show the feature that we choose earlier. So here, the greater the bar graph here, it means it influence more in predicting the value of uh, the target that we just see earlier, which is deposit. So the most important is duration, and then followed by month, outcome, contact, and so on. So we also have uh, negligible features, which is not really contribute in anything to predicting the value that we choose. Okay, and then proceed. I will choose XGBoost and then add model and continue to workflow. Alright. So here we have our XGBoost here. Okay. So here to predict our value. Okay. So here the correct sample earlier we have this validation sample. So we just drag this and connect it with the predict value tools here. And oops, just like that here. And then we wait. And then go to in and out, go to browse and connect it with predict value too. And then we run to see the outcome. So here is the outcome here. So this is the deposit, the original deposit, the value, and this is the predicted value based on the feature that we choose earlier. And then this is the percentage of no the no decision, and this is percentage of failure. So because this is yes is more larger than no, so the answer is yes. So and so on. Okay. So here uh we can also see the output here. So let's scroll down and then alright, this one. So this is the original deposit, the where the customer subscribe to the term deposit, and then this is the predicted value. So as you can see, actually the value is not really that uh, difference. So it's actually quite accurate to say the least. Okay. So that's all from me. Thank you.
Assalamualaikum and good days. My name is Nur Kuzari Zakwan bin Muhammad Zamri. My matrix ID is A21EC0112 and I'll be presenting data mining technique about regression. Okay, so first we need to import our data to this Alteryx. We just click on input and set up connection and find the data. So for this one, I'll be using the CSV file, but any other file is like SLX or PDF also can. But for my case, it's CSV file. Okay, it will show all the data here, but only 100 first records. And then for the CSV file, the data will be converted to in the data type. All the data type will be converted into string. So I'll be change it accordingly. For example, each is double or integer, but it changed to string. So I'll be change it accordingly. Okay, for this case, I'll be only using two data, which is talach and age. Talach is maximum heart rate reach. Okay, I'll be converting it to double, and I'll just tick on what I'll be using, talach and age. Okay, and then connect it with the sample. Okay, for the sample size, we want to minimize the data. The data here, it has thousand of data. So I'll be minimize it to minimize the time processing. Okay, I'll be using one of every n rows, which mean that for the n I'll be set 5. So for every 5 rows, it only will take one data. Okay, and then I'll be using the linear regression, of course. Linear regression, which is um, for the regression analysis, of course. And then I'll be using the scatter plot to observe the graph. And the Spearman correlation, just connect it with the data we use. We already pre-process. Okay, this is the first pre-processing, which convert the data type and also choose the field of data. And then the second data preprocessing is minimizing the data. Okay. Okay, we need to for the all here, we need to choose the target variable. Okay, for the target variable, we want to predict the value of tallage, which is maximum heart rate reach, and then the predictor value is age. Okay, and then here the x horizontal field will be using age, and the y vertical field will be using tallage. Then r here we want to know the bonding between the relationship is strong or not. Okay, I'll be using age and tallage. Okay, and then for the end of it, I'll be using output. I'll be using browse to see the output. Okay, for this browse, it will show all the necessary information for each of the tools. Okay, we must put it at the very end. Okay, but I like to use core tools. This is a very great tools for Alteryx designer. It predict value or classes of a new data set using an existing predictive model. It's very good. Okay, I'll be connecting this D with the output of the linear regression, and then also the M, which is model. If you want to know what this means, you can click there and it will show here model. For this one is data, for this one is output, R is reports, and I is interactive report. Okay, I'll be connecting output with the data, and then our data here with the model. Okay, we make it smaller here, and then of course the browse value. I mean the browse value at the very end, and then we use scatter plot. We use the Spearman correlation. I will show you what does it makes the difference. Okay, connect this with the browse, and here also the browse. Okay, here we choose the score, and here we choose age and also the score. We not use the tallage. I'll show you what it does later. Okay, then all here already connected. I'll be click on run. It will run for a while. If we use all the data here, it will take a longer time. So I just use just like one of every 5 row, so it takes less time to process. Okay, here it shows you the report of linear regression, all the necessary detail for the estimate. We estimate negative 0.97545, which means that every age. Okay, I will show you the graph. Okay, every age increase, it will decrease the heart rate, max heart rate reach. Every one age increase, it will decrease negative 0.975, like here, 9745. And then okay, for this one, it has also the graph. It shows you the graph, all the necessary details, coefficient and everything. And for this one, we will show you the interactive graph, interactive report, R squared, adjust R squared, and everything about regression. And then here for the scatter plot, it will show you the graph of the age versus tallage. And then for this one, it will show you the bonding of the correlation between age and tallage. Okay. Okay, for this one, the score one, it is very good. As you can see that it will just predict at the age of 30, you will have the about 175 max heart rate reach. Okay, we will compare this one with the data we use here. Okay, at the age 30, 175. Okay, we find here age 30, it's about here. You can see that this is 29, and it's about between here, it's about 175, like that. For this one, for example, for the age 40, 165, And then for this one here at the age 40, it's around here. The max heart rate reach around here. So it's very good tool. And for the experiment correlation, of course, it already simplify the data. It will zero the correlation, the bonding, the relationship is 0.9965, which is very strong because it's already minimized. It already simplify the data. Okay, I think that's all from me for the regression part. Um, for more explanation, I already explained in the report. I think that's all from me. Thank you and Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hassan bin Abdullah, and I am going to continue with the clustering data analysis workflow. Okay, so I've already set up the Insight Alteryx Designer, and I've already run the program so that I can better show the outputs and guide you step by step. So first is we use the input data tool, which can be found in the in/out toolbar, and I have used two of them here. First one contains the main dataset, which is caffeine.xlsx. I've sourced this from kaggle.com, and it contains information on around 610 different beverage brands, including information on the name of the brand, the caffeine content, how many calories are in it, the volume, and the type of drink. So the type of drink is separated into either coffee, water, tea, energy drinks, energy shots. And then we have this Excel sheet that I've made myself, which is called replacement values. And as you can see, we have the field value and replacement. So this is used later in find and replace, and I'm going to explain after this. So next, we use the select tool, which can be found inside of the preparation toolbar. The function of this tool is to change the data type of the selected field. And so for our case, I have used it to change the data type of both field value and replacement inside of replacement values to v strings from double, so that we can use them in this find replace tool. And so what's the function of this find and replace tool? It's basically to identify and search for values inside of a specific field that we are looking for, then change it with the specified value. So connected to the F input is the main dataset, and I want to search within the field type for a value which is identical to the field value inside of replacement values. So if the type of the drink is, for example, coffee, I want to change it to 1. If it's energy drinks, I want to change it to 2, and so on. And why do I want to do this? Because for clustering, especially in Alteryx Designer, we cannot use categorical data, and so we have to change certain data types, for example, strings, into integers or doubles. And so I'm using this temporarily so that I can find and use these fields for the clustering method. Okay, so the output of this will be that each row of data will now have their types numbered instead of categorical. So we use the select tool again to change the data type of field type from string to double. So that's all for the data preprocessing part. Next, for the clustering algorithm, we start with the standard scalar tool. Now, this tool is used to standardize the rows of data in our dataset so that we can manipulate and show the relations between the data much more clearly, because the range between the data is quite large. And there's also another method to do this, to standardize the data inside of the K-centroid cluster analysis tool. But I found that using this downloadable tool from Alteryx Designer's website to be much more convenient and also more and produces a more accurate output. All right. So next we use the K-Centroid diagnostic tool, which can be found inside of the predictive grouping toolbar. And we use it to help identify the ideal number of clusters to use when clustering. We select our interested fields. For in our case, we are interested in comparing the calories, caffeine, and type of the drink. And we use the k-means clustering method. And for our purpose, we are going to use this configuration, which is minimum number of clusters set to 2, maximum number of clusters set to 6, and so on. And so we can use the browser tool from in/out toolbar to take a look at the diagrams. So if we scroll down, you can see that there are two box plot charts. The first box plot that we can see is used to show us how similar the values within each clusters are. So the smaller the box plot, the better it is, because each cluster is more dense, more smaller. The second box plot chart is used to show the difference of points between each cluster. So you want this to be as different, you want clusters to be as different as possible from each other. So we use the median of each box plot chart to show us how different it will be. And so after considering both, it is suffice to say that we can take a compromise between these two charts and pick 3 as the ideal number of clusters. So the next tool we'll be going to use is the K-Centroid cluster analysis tool. So we're going to set the configuration as follows. Choose the same 3 fields to consider and use k-means clustering method, and then set number of clusters to 3 and number of starting seeds to 20. So the output of this will be, as you can see here. So what is understandable from this output is that we can see that each cluster has around different numbers of data points. The first cluster has a size of around 283 drinks. Cluster 2 has around 180. Cluster 3 has 147. And the average distances between these three clusters is almost the same, while the max distance between the values inside of each cluster is very much different, with cluster 1 having the highest value, while cluster 2 having the most almost the same values for each of the set. So the convergence was achieved after 8 iterations, and the sum of within cluster distances is 556.471. This value indicates that the overall distance between the observations within each cluster, with a lower value indicating tighter and more well-separated cluster. And so this report also provides a matrix that shows the standardized values of the variables, i.e. calorie, caffeine, and type. So each row responds to a cluster, and the columns represent the variables. So what we can infer from this is that cluster 1 has below average values for calories, which is negative 0.6, and type, which is negative 0.59, but an above average value for caffeine, which is 0.36. For cluster 2, it has also similar values, which is negative 0.04, which is more below average compared to cluster 1 for calories, and also the same for caffeine, but a higher above average value for type, which is 1.376517. And for cluster 3, it has higher above average value for calories, which means it has higher calories content. And on the flip side, negative 0.04 or almost average amount of caffeine, and negative 0.54 to 0.05 shown, which means that it has quite a differentiation in the types of drinks in it as well, comparable to cluster 1. So this is the cluster or the scatter plot. So the next step is to use the pen cluster tool, also from the predictive grouping toolbar, to add the generated cluster to each row inside of the main dataset. So we do this by attaching the O output from the k-centroid cluster analysis to the append clusters first input, while we attach the second input to the main dataset. So after that, I've also included yet again the replacement values input and dataset so that I can change back the values of the type field. So change it back from numbering to the actual categorical value. As you can see, I've flipped the settings. So when I generate the output using the output data to another spreadsheet, it will be like this. So you can see there's another extra field called cluster. So it assigns the cluster that's generated to each row. So you have a lot of drinks belonging in cluster 1, a few in cluster 2, and then the rest in cluster 3. Okay, so the next step is for discussing the output. So I've used this interactive chart tool from the report toolset to generate these informative graphs. So I've generated 2 bar charts to compare the clusters and the sum of the calories inside the drinks in each cluster. So in the first bar chart, you can see that there are almost 50,000 milligrams of caffeine inside the drinks of the first cluster, and only minuscule amounts of caffeine in the second cluster, and half of the first cluster, half of the amount of caffeine in the first cluster in the third cluster. It basically, the opposite can be said about the amount of calories inside of each cluster. Cluster 2 has absolutely no calories. Cluster 1 has minuscule amounts of calories compared to cluster 3. So most of the concentration of calories is inside the drinks that is assigned to cluster 3. Next, I've also made these 3 tables which show the type of beverage inside of each cluster. For example, inside of cluster 3 and inside of cluster 1 and inside of cluster 2, so the amount of drinks of each type inside of each cluster. And I have also made a unified bar chart table. This is a more clearer view of the amount of each type of drinks inside of each cluster. As we can see, there is a high concentration of energy drinks, coffee, and soft drinks inside of the third cluster, while in cluster 2 there is no coffee and no energy shots whatsoever, and consists purely of energy drinks, soft drinks, tea, and water, which makes sense because cluster 2 has almost no caffeine whatsoever and 0 calories. While in cluster 1 we have much lower values of each type of drink, but with coffee and energy drinks leading. So the next graph that I made is the scatter plot of each cluster. You can see it visualizes what we already found out from the uh, previous outputs that we gained. So you can see that the orange one represents cluster 3, the blue represents cluster 1, and the green represents cluster 2. And you can see that the drinks in cluster 2 has almost no calories and almost no caffeine whatsoever, while drinks in cluster 3 are higher in calories and most have some caffeine content as well, while the drinks in cluster 1 has much lower calories but higher caffeine content. That's all from me. Thank you.
Hi, my name is Wan Amir Rafiq, and right now I'll be explaining to you about data mining task, association rules, a priori algorithm. Okay, so first we have to go create a new workflow here using Alteryx designer here, and then click on here the input data to upload the database, the file. Click here, set up the connection, and this is my file, which is about online retail. After uploading, here as you can see the file here with the description and invoice number, and then we go to filter here. This is for data pre-processing. Filter, click on the filter here, and then there's a basic filter here, column. First we want to select invoice number, and here set to is not null, and you can also use this one, browse, to see the data. For example, here I put here and here, and I click run. So here you can see the data here. We got invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. And here is after the filter. So the T and F here stands for true or false. If this false, it will go here. So as you can see, 0 records displayed. It means that the invoice number, all of them is not null. And then we continue to filter here, put here. So for this filter, I will put description here to set it to not null. And also I will put another filter here and set the quantity is larger and equal to than 0. So it means that if the quantity is negative, it will not be read. And I click run here. So as you can see here, so this filter managed to filter out all the null in the description here. And for this one, you can see the description here, negative quantity here, and 0, it filtered out. So then we can continue to our data mining task, which is priori algorithm. So at the toolbar above here, you can see there's predictive grouping here. So first here we have find the nearest neighbor, case centroid diagnostic. So first we drag MB rules here, So now going to the configuration, I'm gonna select the transaction key field for invoice number and description. So for method to use, we will use a priori and not that. To use a priori and association rule here. And for control parameters, I leave it as a default. And again, use browse here. Also, I'm gonna use MB inspect here to view the MB rules here. And also, I'm going to set this to a default. And also use the browse to see the output here. And I'm going to click run. It's going to take a while because the data is big. So the MB inspect function is actually to select only a few of the records here. So for here is the final answer, the final output here. So you click here, browse here, and on your left you can see all the data, lift, confidence, support, right hand side, left hand side, and here is the output here, output table here. We have left hand side, we have jumbo back pink polka dot and jumbo back red retro spot, and here is the support, confidence and lift. So we have O and R here. You all can also click R here to view inspection report here with all the values here, and also the graph. So basically here is the final output for this a priori. So for this algorithm, you want to check in the online retail place which items that customer buy and usually buy another one. So here left hand side here, so customer often buy jumbo bag pink and also buy jumbo bag retro sport here. So here is the confidence, support and lift. So that's all from me. Thank you.